In this demonstration, I am going to illustrate the effects of surface area. So I'm going to start with taking some sawdust that we got from our local wood shop here. And this sawdust is finely ground wood. And we know that wood reacts with the air and combusts. So I'm just going to make a little pile of sawdust. And it's going to react with the air and combust, like I said. And what's happening is the carbon in the cellulose is going to lose its electrons to the oxygen and make stable CO2 and water in this reaction. And we need some activation energy to start that to overcome the activation barrier. And so when I light this and apply the activation energy, you can clearly see that a fire has begun, combustion has begun, okay, and that the cellulose or the wood, okay, is in fact burning. But it's not burning at a very fantastically fast rate, very slow rate. Only the outside of the pile of sawdust is burning. In fact, now it's out. So not a terrifically fantastic rate of reaction here. But what I can do is I can take that dust, and what I can do is, if I was to expose all of that dust into powder over a flame, the rate of reaction would increase. So what I'm going to do is something called a grain elevator explosion, or at least it's going to be a mini one anyway. So what I'm going to do is take a can, as you can see here, and it's got a tube coming out, and inside the can I have a candle and I have some more sawdust. So let's take a gander at what's going on inside the can here. So inside the can, okay, you can see the candle, and you can see that there's my candle I'm going to light, and here's the inner compartment where I'm going to blow air into to create the dust. So let's do it. So I'm going to light the candle, and again, I'm after something called a grain elevator explosion. So I'm looking to see if I can create somewhat of an explosion upward when I blow through the can. Alright, so let me light the candle. I already have sawdust in that inner compartment that I showed you. Of course, I have to have a lighter that works. Okay, so my candle is lit. There's my activation energy. I'm going to put a loose top on this, and we're going to blow the same sawdust in that little compartment into a dust that's going to go over this flame, and just by exposing more atoms, increasing the number of effective collisions, or the number of effective collisions will occur. Okay, so I'm going to blow through this hose, and here we go. 1, 2, 3, and there's my very interesting reaction that caused, essentially called a grain elevator explosion, that has happened in wood mills, has happened in flour mills. Anywhere we're crushing powder that can burn, you can create a scenario of an explosion, because those fine powders can essentially cause a fast rate of reaction, which a great example of that is an explosion, because when you have dust particles exposed to every single oxygen, when you allow for more of the reactants to collide with others, the rate of reaction increases. So what I'm going to do now is I'm going to take an alcohol burner, and I'm going to do something called dragon's breath, and I'm going to blow that same finely grit powder, and I'm going to blow that powder over a flame. And again, all I'm using is sawdust, nothing fancy here, and I'm looking for a incredibly rate of reaction as I blow that powder through the flame. And again, the rate of reaction is going to be much faster than I did lighting the clump of sawdust, only because I'm now exposing more atoms to the reactive oxygen. And when the oxygen is exposed to more of the cellulose of the powder, we have a faster rate of reaction, only because we've increased the surface area. So let's try this. Okay, 1, 2, 3 here. Okay, let's do that a couple more times. That was pretty fun. Again, I'm just taking sawdust. And sawdust, as you can see, was extremely slow rate of reaction we had earlier. Okay, it was not very volatile at all when I lit it before because it was only burning on the outside. It's only exposing a small amount of those atoms to the oxygen. Whereas now I'm exposing all of them at once, so the rate of reaction increases when the surface area increases. Here we go. Okay, that was pretty lame. One more time. Okay, just putting some more in. Here we go. And that is the dragon's breath demonstration, surface area demonstration.